Every single day, fishing fleets across the Pacific Ocean catch over 200,000 tuna. That means in just 1 year, more than 70 million of these magnificent fish are pulled from the ocean depths and transformed into the sushi and sashimi that appears on plates in restaurants from Tokyo to New York. But how does a 600-pound bluefin tuna swimming freely in the Pacific become perfectly sliced sashimi in a high-end restaurant just 48 hours later? Welcome to AgriCraft, where we explore the incredible industrial processes that bring food from its origins to our tables. Today, we are diving deep into one of the most sophisticated and high-stakes food production systems on Earth. The journey from ocean to plate involves cutting-edge technology, precision timing, and industrial operations that would make any agribusiness professional take notice. How do fishing crews locate schools of tuna in the vast Pacific? What happens inside those massive processing plants where thousands of fish are handled every hour? And why is a single bluefin tuna worth more than most cars? All will be revealed in this video. The story of commercial tuna fishing begins in the early 1900s when Japanese fishermen first developed techniques for catching these powerful oceanic predators. But the scale we see today is absolutely mind-boggling. Modern tuna fishing has evolved into a $20 billion global industry that combines ancient maritime knowledge with space-age technology. Countries like Japan, Taiwan, South Korea, and the United States operate fleets of vessels that can stay at sea for months, traveling thousands of miles to reach the prime fishing grounds where tuna migrate in massive schools. What makes this industry so fascinating is the incredible value of the catch. A single giant bluefin tuna can sell for over $300,000 at the famous Tsukiji fish market in Tokyo. That is more than most people pay for a house. The reason for these astronomical prices lies in the unique biology of these fish and the incredible demand for high-quality sashimi-grade tuna in Japanese cuisine and increasingly in restaurants worldwide. Tuna are among the most remarkable fish in the ocean. Unlike most fish that are cold-blooded, tuna can regulate their body temperature, making them incredibly powerful swimmers capable of reaching speeds over 40 miles per hour. They migrate thousands of miles across ocean basins, following currents and food sources and patterns that fishing fleets have studied for decades. The three main species targeted by commercial fishing operations are yellowfin tuna, big-eye tuna, and the most valuable of all, Atlantic and Pacific bluefin tuna. The scale of modern tuna fishing operations is staggering. A single purse-seine vessel, which is the most common type of tuna fishing boat, can be over 300 feet long and carry nets that could cover several football fields. These ships are equipped with helicopter landing pads, massive refrigeration systems, and fish holds that can store over 1,000 tons of tuna. The largest fishing companies operate fleets of dozens of these vessels, creating floating cities that harvest the ocean with industrial efficiency. But finding tuna in the vast Pacific Ocean requires technology that would impress any precision agriculture specialist. Modern fishing vessels use satellite imagery, sonar systems, underwater cameras, and even artificial intelligence to locate schools of tuna. Fish aggregating devices, or FADs, are deployed across thousands of square miles of ocean. These floating structures attract smaller fish, which in turn attract the tuna that feed on them. Each FAD is equipped with GPS tracking and sonar that can detect when large schools of tuna are nearby. The actual fishing process is a carefully choreographed operation that combines traditional skills with modern industrial machinery. When a school of tuna is located, the fishing vessel deploys its purse-seine net, which can be over a mile long and several hundred feet deep. Speedboats work in coordination to encircle the school of fish. Then the bottom of the net is drawn closed like a giant purse, trapping thousands of tuna inside. The harvest from a single set can be extraordinary. A good day might yield 500 to 800 yellowfin and big-eye tuna, each weighing between 100 and 400 pounds. But it is the occasional giant bluefin tuna that makes headlines. These magnificent fish can weigh over 800 pounds and represent decades of growth in the ocean. The moment one of these giants is brought aboard, fishing crews know they might have caught a fish worth hundreds of thousands of dollars. Once the tuna are brought aboard the fishing vessel, the race against time begins. The quality of sashimi-grade tuna depends entirely on how quickly and carefully the fish are processed and frozen. This is where the industrial precision of modern fishing operations becomes apparent. Each fish is immediately evaluated for size, species, and quality. The most valuable fish are quickly processed using techniques that would be familiar to any food processing professional. The fish are first bled by cutting specific arteries, a process that must be done within minutes of the fish being caught to maintain the quality of the meat. Then they are cleaned and prepared for flash freezing. The freezing process is absolutely critical and represents some of the most advanced food preservation technology in the world. Ultra-low temperature freezers on board these vessels can bring the core temperature of a 400-pound tuna down to -60 degrees Fahrenheit in just a few hours. The transportation of these frozen tuna from fishing vessel to processing plant involves a complex logistics network that rivals any agricultural supply chain. Specialized cargo ships equipped with massive refrigeration systems collect the catch from multiple fishing vessels and transport them to processing plants in Japan, Taiwan, Thailand, and other major tuna processing centers. Some of the most valuable bluefin tuna are flown directly to markets in Japan on cargo planes, maintaining the cold chain from ocean to auction house. When these frozen tuna arrive at major processing plants, they enter facilities that process thousands of fish every day. These processing plants are marvels of industrial engineering and food safety technology. The Yaizu plant in Japan, one of the largest tuna processing facilities in the world, can process over 3,000 tuna per day during peak season. The facility covers over 50 acres and employs more than 2,000 workers. The processing begins with thawing, which is done in carefully controlled temperature rooms that gradually bring the fish back to working temperature while maintaining the quality of the meat. Quality inspection teams examine each fish, looking for the marbling, color, and texture that determine whether a tuna will be graded as sashimi quality or processed for other uses. The grading process is incredibly sophisticated and requires years of training to master. Inspectors use core samples taken with special tools that extract small plugs of meat from specific locations on the fish. These samples reveal the fat content, color, and texture that determine the final grade and price of the tuna. The highest grade tuna, called Otoro, comes from the fatty belly portion of large bluefin tuna and can sell for over $400 per pound at retail. Once graded, the tuna move through the processing plant on automated conveyor belts that transport them to different sections based on their intended use. Sashimi-grade fish are handled by master butchers who use techniques passed down through generations to break down the fish into specific cuts. These craftsmen can process a 400-pound tuna in less than 30 minutes, separating the different grades of meat with surgical precision. The industrial machines used in modern tuna processing plants combine traditional techniques with cutting-edge automation. Bandsaws designed specifically for frozen fish can cut through a massive tuna with incredible precision. Automated systems sort the different cuts by grade and package them for distribution. Temperature control throughout the entire process maintains the cold chain that preserves the quality that makes this tuna so valuable. The packaging systems in these facilities are designed to maintain product quality during global distribution. Vacuum packaging removes air that could cause deterioration, while specialized containers maintain precise temperatures during shipping. Some of the highest grade tuna cuts are individually wrapped and labeled with tracking information that allows them to be traced back to the exact fishing vessel and date of catch. The distribution network for processed tuna reaches every corner of the globe. Refrigerated trucks transport the packaged fish from processing plants to airports where they are loaded onto cargo planes equipped with temperature-controlled holds. A piece of tuna caught in the Pacific on Monday can be served as sashimi in a New York restaurant by Wednesday, maintaining the same quality as when it was first processed. The scale of this distribution is remarkable. Tokyo alone imports over 400,000 tons of tuna annually, while the United States imports over 300,000 tons. This represents millions of individual fish processed through industrial systems that ensure consistent quality and food safety standards that meet the requirements of the most demanding markets. Beyond the premium sashimi market, tuna processing creates numerous byproducts that support other industries. Lower grade meat is processed into canned tuna, a market that consumes over 4 million tons annually worldwide. Tuna oil extracted during processing is used in cosmetics and supplements. Even the bones and scraps are processed into fish meal used in animal feed and fertilizer, creating a zero-waste system that maximizes the value of every fish. The nutritional value of tuna makes it one of the most sought-after protein sources in the world. Tuna is incredibly rich in high-quality protein, containing all essential amino acids. It is also an excellent source of omega-3 fatty acids, particularly EPA and DHA, which are crucial for heart and brain health. A single serving of sashimi-grade tuna provides over 30 grams of protein while being naturally low in saturated fat. The culinary applications of processed tuna extend far beyond traditional sashimi and sushi. High-end restaurants create elaborate preparations that showcase the different textures and flavors of various cuts. The fatty Otoro melts at mouth temperature, while the leaner Akami provides a more substantial texture. Chefs use techniques like aging and curing to develop even more complex flavors from this remarkable fish. The environmental impact of industrial tuna fishing has become an increasingly important consideration for the industry. Sustainable fishing practices are being implemented by major fishing companies to ensure that tuna populations remain healthy for future generations. These include quotas that limit the total catch, restrictions on fishing in breeding areas, and requirements for using fishing methods that reduce bycatch of other species. Many processing plants have implemented sustainability programs that track the source of their tuna to ensure it comes from responsibly managed fisheries. Certification programs like the Marine Stewardship Council provide consumers with assurance that their tuna was caught using sustainable methods. Some companies are even investing in tuna farming operations, though these are still experimental compared to the scale of wild-caught operations. The technology used in modern tuna fishing and processing continues to evolve. Satellite tracking of fishing vessels allows for better management of fishing quotas and ensures that vessels are operating in legal fishing areas. DNA testing can identify the exact species and even the region where a tuna was caught, providing unprecedented traceability in the supply chain. Artificial intelligence is being integrated into processing plants to improve quality grading and reduce waste. Computer vision systems can analyze the marbling and color of tuna meat more consistently than human inspectors, while robotic systems are being developed to handle some of the more repetitive processing tasks. These technological advances are making the industry more efficient while maintaining the quality standards that make premium tuna so valuable. The economics of the tuna industry demonstrate the incredible value that can be created through sophisticated processing and distribution systems. While a fishing vessel might receive $10 per pound for a yellowfin tuna at the dock, that same fish can generate over $50 per pound in retail value after processing and distribution. For premium bluefin tuna, the value multiplication is even more dramatic, with dock prices of $20 per pound becoming retail prices of several $100s per pound for the finest cuts. This value creation happens through the industrial processing systems that transform a whole fish into precisely cut, perfectly preserved, and carefully graded products that meet the exact specifications of restaurants and retailers around the world. The processing plants, distribution networks, and quality control systems represent billions of dollars in infrastructure that makes this transformation possible. The workforce required to operate these systems includes everyone from fishing crews who spend months at sea to highly skilled butchers who can grade and process the most valuable fish in the world. Training programs in countries like Japan take years to complete, as workers learn to identify the subtle differences in quality that determine the value of each fish. This combination of traditional knowledge and modern industrial processes creates products that command premium prices in global markets. Looking at the entire system from ocean to plate, the industrial scale of modern tuna fishing and processing is truly remarkable. From the massive fishing vessels that harvest the ocean to the processing plants that handle thousands of fish daily, every step is optimized for efficiency, quality, and safety. The result is a global industry that delivers one of the world's most prized food products to consumers everywhere while supporting hundreds of thousands of jobs and billions of dollars in economic activity. The transformation of tuna fishing from small-scale traditional operations to the massive industrial systems we see today represents one of the most dramatic changes in food production in the past century. The technology, logistics, and processing capabilities required to deliver fresh sashimi-grade tuna to restaurants around the world rival any agricultural supply chain in complexity and sophistication. From those initial moments when fishing crews spot a school of tuna in the vast Pacific to the final presentation of perfectly sliced sashimi on a restaurant plate, every step of this journey demonstrates the incredible capabilities of modern food production systems. The coordination required between fishing vessels, processing plants, transportation networks, and retail operations shows how industrial agriculture and food processing have evolved to meet the demands of global markets. The precision timing, quality control, and technological sophistication of the tuna industry offers lessons that apply across all areas of food production. Whether we are talking about harvesting grain in the Midwest or processing vegetables in California, the same principles of efficiency, quality, and safety that drive the tuna industry are transforming agriculture and food processing worldwide. Thank you for joining us on this deep dive into the incredible world of industrial tuna fishing and processing. The scale and sophistication of this industry truly demonstrates how modern food production systems can transform natural resources into products that feed the world. If you enjoyed learning about these remarkable industrial processes, please give this video a like and subscribe to AgriCraft for more fascinating looks at the food production systems that feed our world. What other food production processes would you like us to explore? Let us know in the comments below.